All right, so today we're going to talk about the empirical rule and the normal distribution. So normal distribution is a specific type of symmetrical distribution, which is also known as the bell-shaped distribution, or we call it a bell-shaped curve, because if you notice the shape of what we have right here on our paper, looks like a bell. So this distribution is symmetrical about the mean, and we use this Greek symbol, which we call mu. And it's based on the mean and standard deviation. So the standard deviation, we use this Greek symbol sigma, it's lowercase. And the total area underneath our bell-shaped curve is equal to 1. So let's go ahead and look at this. So symmetric about the mean, which if we draw a line down here in the middle, so that means that this is the mean. I'm going to label that with our Greek letter mu. And so what this says is that if we were to draw some lines down here, that this first one is the first standard deviation from the mean. And we've learned about standard deviation in prior math courses. So this is also the first standard deviation. From the mean. So the way that we write that, we would just write the mean plus 1 standard deviation. So then this next mark would be 2 standard deviations from the mean. So the mean plus 2 standard deviations. And then the last one would be 3 standard deviations from the mean. So the mean plus 3 standard deviations. So let's actually look at an example for this. All right, so for our example, it says, let the mean equal 12 and the standard deviation equal 5. We're going to draw a normal distribution based upon the bell-shaped curve. So let's go ahead and draw our curve as best we can. There's my curve. So the mean, which is 12, would be right in the middle. So within 1 standard deviation of the mean, if it's to the right, we're going to add the standard deviation. If it's to the left, we're going to subtract. So if I do 12 plus 5, that gives me 17. And 12 minus 5 gives me 7. So those are within, the 7 and 12 is within, the 7 and 17 is within 1 standard deviation of the mean, which is 12 in this case. So if I want to do the next one, 2 standard deviations of the mean, we add another 5 and subtract another 5. So 7 minus 5 is 2, and 17 plus 5 gives me 22. So those are within 2 standard deviations of the mean. And then we, of course, have 3 standard deviations of the mean. So we subtract another 5, we get -3, and this would be 27. So that would be our normal distribution based upon the mean being 12 and the standard deviation being 5. Now, a lot of times in these word problems, we'll see these types of questions. It'll ask for the probability. So if it asks for probability, and we'll talk about this a little bit more, but you're going to be using the decimal answer. If it talks about percent, you're going to multiply your decimal by 100 so that you can put it into a percentage. And if it asks for how many, you're multiplying the decimal by the total number. And again, that'll make more sense when we do some of these problems. So make sure you have all this written down, because next we're going to actually look at then what the empirical rule is. The empirical rule, which is the 68, 95, 99.7 rule for normal distribution, It shows the connection between the normal distribution and the standard deviation. So what we say is that 68% of our data is going to be between plus or minus 1 standard deviation of the mean for a normal distribution. 95% of the data is between plus or minus 2 standard deviations of the mean, and 99.7% of the data is between plus or minus 3 standard deviations of the mean. And again, that's for a normal distribution. So here we have the mean. This would be plus 1 standard deviation, plus 2, plus 3, and on the left side is minus 1, minus 2, minus 3. So for this, we are saying that within 1 standard deviation of the mean, which would be from here to here, so this area, which is the area underneath the curve, so all of that is 68% of the data, or of the area, so 68%. So then the next part is, it says 95% of the data is within 2 standard deviations of the mean. So 95% of the data then means we're going from here all the way over to here. So now we're going to do this, add these sides over here to all of that. So that would be from here, and that was 95% to here. And then the last one within 3 standard deviations is 99.7% of the data. So that would go from here all the way to here and include that whole area underneath the curve. So we can figure out then the what part of the area, so the percentage for each of these individual parts. So if 68% of the data is in between 1 standard deviation of the mean, then that's really, of course, 0.68, because the total area underneath the curve, we use the decimal. So if the total area under the curve is 1, so then if 68% of the data is within 1 standard deviation of the mean, 0.68, well, if you divide that by 2, that means this is 0.34, and this would be 0.34. And 95% is within 2 standard deviations. So I can figure out the decimal percent here and here by subtracting. So if I do 0.95 minus 0.68, that gives me 0.27. And if I divide that by 2, I get 0.135. So 0.135. And then we know that from 3 standard deviations, the mean is 99.7. So we know this, again, was 0.95. This would be 0.997. So if I want to figure out this area and this area underneath the curve, I'm going to take the 0.997 and I'm going to subtract it from 0.95, and that gives me 0.047. Divide that by 2 because we have it on both sides, and that gives me 0.0235. So this would be 0.0235. And then we want to figure out this last little bit, what that area is. And so again, the total area underneath our curve is 1. So 1 minus 0.997 would be equal to 0.003. Divide that by 2, and we get 0.0015. And we're going to be using these numbers when we do our next examples. So let's go ahead and look at the example that we have here. So the example says, adult IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. We want to find the probability that a randomly selected adult has an IQ between 70 and 115 is the first one. So let's go ahead, and the first thing before we even answer the questions is we want to draw our normal distribution as best we can. We're going to draw our line. So we know that in the middle is the mean, which we said was 100. And then our standard deviation is 15. So if I add 15 to 100, I get 115. If I add another 15, I get 130. And another 15 would give me 145. So then if I subtract 15, I get 85. Subtract another 15 to get 70. And subtract another 15 to get 55. So we want to figure out the probability. So again, remember we said probability. If I come back up here, going to take this down so we don't forget, oops, our rules. So again, we want to find the probability that a randomly selected IQ, a selected adult has an IQ of between 70 and 115. So remember, probability means we're going to use the decimal answer, which is from the area underneath our curve. So from 70, which is here, to 115. So we're trying to figure out the probability that the adult has the IQ between these two values. So that means we need to use our empirical rule to help us figure out that percentage, which we're going to use the decimal of the percent. So we know that 68% of the data lies within one standard deviation. And we know that within two standard deviations, we said that was 95%. So we figured on up here, we said that in order to figure out this green part, we took 95 minus 68, and then, or 0.95 minus 0.68 divided by 2. And remember, we got the 0.135 for each side. So we know that if we draw our lines back in, this is 0.34 and 0.34, because that's 0.68, which is 68%. And we know that this is 0.135, and this side would also be 0.135. So if we want to figure out the probability, we're just adding up 0.135 plus 0.34 plus 0.34. And when we do, we get 0.815. So that would be 81.5% of adults have an IQ between 70 and 115. So now we want to figure out the probability that a randomly selected adult has an IQ of more than 85. So more than 85, I'm going to erase this yellow part here, would be from here going all the way this way. So that means we need to figure out all this data here. Well, remember, the total area underneath the curve is 1. So from the mean, if it's symmetrical going this way, if you were to add up all those percentages, you know that that's 50%, right, of the area of the data. So if that's 50% of the data, we're taking that 0.5 and adding 0.34 to that, which gives us 0.84 or 84%. Could you add up all these values that we had found before? So remember that we said this was 0.0235 when we talked about that above on the other page, 0.0015. You could add that all up. So that would be 0.34 plus 0.34 plus 0.135 plus 0.0235 plus 0.0015, that is also equal to 0.84. Just a lot easier to use the fact that we know if it's symmetrical, the curve is symmetrical about the mean, then that's 50% of the data. So then the last part says we want to find the probability that the randomly selected adult has an IQ that is less than 130. So less than 130 would be from here going this way. Oops. So now we're going this way. So for that, again, same thing. We know from here to here is 50% of the data. So we're going to take that 0.5 and then add 0.34 plus 0.135. When we do, we get 0.975. So 97.5% would be our solution for the probability that a randomly selected adult has an IQ less than 130. And then the last question says, if you surveyed 1,500 adults, how many of them would have an IQ between 100 and 145? So if we go between 100 and 145, that would be here. So we're looking at this area of these right here. So we need to add up those probabilities. So we have 0.34 plus 0.135 plus 0.0235, which gives us 0.4985. So that would be the probability. And we want to figure out, remember, probability, it's asking how many would have an IQ. So how many if we surveyed 1,500 adults. So you take your decimal and you're going to multiply by that total number. So we have 0.4985 times the 1,500 adults that we surveyed, which equals 747.75. And for these, we always round up. So we would say 748 adults. And that would be the amount of adults that have an IQ between 100 and 145. And that is it for today.